Hello, everyone. My name is Brahmaji, and I am a student from India participating in the TEEP Research Internship at National Chin-Yi University of Technology, Taiwan. My research topic is elevator health diagnosis. In this video, I will explain the tools, methods, and outcomes of Week 3 from Lab 1 to Lab 7 of my project. For this week task, I used the ESP32 microcontroller as the main hardware, along with push buttons, an LED, a breadboard, and jumper wires. For software, I used Wokwi for circuit simulation and Thonny for MicroPython programming. I first designed and tested each circuit virtually in Wokwi to ensure the logic worked. Then, I uploaded the code to the ESP32 board using Thonny. The push buttons were connected to specific GPIO pins to detect user input, and the LED was used as a visual indicator for different functions. I also used the time module in MicroPython to measure button press durations and to control blinking patterns. In Lab 1, I learned the basics of digital input and output, and also implemented a simple counter. A push button was connected to a GPIO pin and an LED to another pin. Each time the button was pressed, the counter increased by 1 and displayed the value in the shell. The LED also responded to the button press, turning on while pressed. This introduced me to GPIO configuration, button state detection, and using variables to store and display data. Lab 2 introduced time-based LED control. I added 2 buttons. The first button stopped the program and displayed End Program, while the second button made the LED blink with a specific pattern. 3 seconds on and 1.5 seconds off, repeated 7 times. Here, I practiced combining button inputs with precise timing using the time module. In Lab 3, I worked on multiple input handling. When SW1 was pressed, the LED turned on and turned off when released. Pressing SW2 stopped the program with a message. The main focus was creating a loop that could respond instantly to button presses without unnecessary delays. Lab 4 involved detecting multiple button combinations. At startup, the LED blinked slowly. If both buttons were pressed together, All Pressed was displayed. If only SW1 was pressed, the LED blinked quickly 3 times and showed SW1 pressed. If only SW2 was pressed, it displayed SW2 pressed. This taught me how to prioritize button combination checks before single button checks. In Lab 5, I optimized the code by creating separate functions using the def keyword. For example, I made a function for fast blinking and another for slow blinking. This modular approach made the program easier to read, debug, and expand. Lab 6 introduced short press and long press detection. A short press of SW1 made the LED blink once and displayed short press. A long press made the LED blink 5 times and displayed long press. I achieved this by recording the press and release times using the time module. In Lab 7, I created a counter system. Each press of SW1 incremented the counter and displayed the current count. If SW2 was long pressed for more than 2 seconds, the counter reset to 0. The LED blinked rapidly 3 times, and Counter Reset was shown. The LED stayed on when the counter was even, and off when it was odd. This lab combined variable storage, timing, and conditional hardware control. This is our practical circuit using ESP32s. Now we run the every lab task in the Thonny software connected with our practical circuit and check the every output with the circuit. Lab 1, Lab 2, Lab 3, Lab 4, Lab 5, Lab 6, Lab 7. These are the 7 lab tasks which is completed in both Wokwi and the Thonny software. In this weekly task, I gained confidence in using conditional statements, loops, and timing functions. I was able to implement button control, LED blinking patterns, and timing functions with confidence. The use of Wokwi and Thonny made testing smooth, and I appreciated how quickly I could see results after making changes. The tasks were neither too easy nor too hard. They required patience and logical thinking. The memorable moment was when my long press detection finally worked after several trials. It felt rewarding to see the LED respond exactly as expected. The most memorable part was watching my code work exactly as expected on the first try. Through these labs, I learned how to use MicroPython with the ESP32, how to read button inputs, control LEDs, and use timing functions effectively. This process also improved my skills in debugging and working with both simulated and real hardware. Thank you for watching.